Hello everyone, I would like to welcome you all in this online tutorial class of mathematics. Today we are going to discuss about exponential equation. Obviously, it cannot be dealt in a single class. That's why we are going to have a consecutive class, a few more couple of classes, so that the complete idea of exponential equation can be understood in a very thorough manner. And while we are talking about this, I'll be explaining you the concept of exponential equation with few examples. And at the end of each day, there will be some questions for you to practice and get more ideas about the exponential equation. Okay, so let's get started, everyone. Exponential equation. So before we start the exponential equation in a practical manner, let's understand what is exponential equation is all about. Okay, it is such an equation in which the unknown variable appears as an exponent of a base is known as exponential equation. What this statement has said about the exponential equation is exponential equation is actually is an equation, okay, in which unknown variable, please note these things, unknown variables unknown variable appears as an exponent. Exponent means power, okay. Unknown variable, it appears as an exponent of a base. There will be a certain base, and such type of equation is known as exponential equation. All right. So in case of exponential equation, there are certain axioms. Okay. And so before we go to the axiom part, let's understand this, what the statement has said to us. Suppose if 2 is the base, or any, in case of 2, for example, if a is the base, then suppose if there is a exponent power unknown, which is unknown variable, for example, x is the unknown variable, and here I'll suppose m is the unknown variable, okay, which are expressed in terms of exponent, or which are expressed in terms of power or index, whatever we say. So this x and m, they are the unknown exponents. So these kinds of equation, but there must be equals to sign and left and right hand part also. So these kinds of form are known as exponential equation. Okay. So now let's understand what are the axioms of exponential equations. So the axioms are, if a to the power x equals to b to a to the power b. So the idea of exponential equation can be clearly seen here. Here is base a, and here is also base a, and there is equals to sign in between them. So it is an algebraic, it is an exponential equation, or also can be said as algebraic exponential equation. So see, here is base a and here is base a. So they have the same base on both sides of the equation. So now in this case, if a to the power x equals to a to the power b, so the unknown exponent x will be equals to b. This is the first axiom. Okay, so if there are two equal base and their powers are different, then the unknown variables or unknown power variable can be equalized with the other side's power. That means, for example, very easy example, if we have 2 to the power, suppose r, let us consider r is the unknown exponent, and then equals to 4, then we can write 2 to the power r equals to 4 can be written as base 2 to the power 2. So that means, because of being base and base same, power and power will be equal. That means r will be equals to 2. That means the value of r will be equals to 2. So this is the basic idea of one of the first axiom of exponential equation. Now, the second thing is, if a to the power x equals to 1, this is another exponential equation. If a to the power x equals to 1, then we know that 1 can be expressed in certain base to the power 0. Okay, it can, previously it was also being talked through the zero law of index. So a to the power x, or as it is from the left hand side, but we know that as we need to make the bases same, so to make the base same, I have written a on the right hand side, the space, and we know that a to the power 0 will again give us the value 1. So due to that reason, 1 can be written as a to the power 0. So again, from the first axiom, we can say that x is equals to 0. So actually these are very much connected idea, only the idea of one is somehow unique here. So these are the two axioms of exponential equation. That means if the bases are same on the either side of the equals to sign, then their powers will be equal, which can be understood from the first law or first axiom. And the second condition, if exponential equation on either side, suppose a to the power x equals to 1, then 1 can be written as the same base, whatever on the left, whatever was on the left hand side, that to the power 0 can be written, so that the exponent or power can be equalized. So to clarify a little bit further about the second axiom, I would like to give you one example. For example, if we have 3 to the power x equals to 1, just for an example, let us consider this is the idea that 3 to the power x is there. So easily 1 can be written as 3 to the power 0. For our understanding, as I have already cleared you that bases can be or should be made same. So we know that 3 to the power 0 is again 1. So by the axiom of exponential equation, we can say that x equals to 0. So this is the idea of axioms of exponential equation. I hope that you have got clear idea about what is exponential equation and what are the axioms or what are the conditions or what are the laws of this exponential equations. All right. So briefly, if we try to conclude the axioms, then first thing, if the bases are same on the either side, then their powers will be equal. And the second one, if there is one on either side, then one can be written as the same base as we can see on the other side in terms of zero power, so that the again indexes or powers can be equalized. Okay, now everyone, let's go to our next thing. Now in the next part, we'll be discussing about some of the applications question. Okay, some of the examples of exponential equation. All right, let's get started. Question number one, solve. Let's see that. Okay, if we see this question number A, now we can see clearly here that there is 3 to the power x or 3 index x on the left hand side, whereas 27 on the right hand side. So we know that 3 is the lowest term or the prime numbers which cannot be reduced into further. That means it cannot be broken down further. But if we look at the 27 on the right hand side, easily 27 can also be written in terms of base 3. Yes, so that means 27 can be written as 3 cube. That's really good. Okay, so 27 can be written as 3 cube. Now if we see, or if you remember the axioms of exponential equation, then we know that if a to the power x equals to a to the power b is there, then power and power will be same. Because of being bases are same, powers and powers will be same. So with the same concept, since there are base 3 on the both sides of the exponential equation, so due to that reason, x will be equals to power 3. So x will be equals to power 3. Okay, power x equals to power 3. So in this way we have solved and we have got the value of x as a 3. So this is our first example. Now let's see the second example. Second example, 5 to the power 2x plus 1 equals to 1 by 125. Now if we see the same thing here, we can see that there is base 5 and which cannot be further broken down. It is the lowest prime number in case of 5, 2, 3, 5, 7 and so on. So in this way 5 cannot be broken down further. But if we see 125 here, 125 can be broken down into lower terms. So that means if we see properly, then 125 can be written as, that's right, 5 cube. Yes. So the same thing that we can see in this first step. So what we have done here is we have written 125 as a 5 cube. Now, as we have already clear about the laws of indices chapter, so by taking the help of laws of indices, now 5 to the power 3 here is on the denominator. So if we just take it up, then yes, obviously it will be 5 to the power minus 3. That's right. It will be 5 to the power minus 3 times 1. So 1 times 5 to the power minus 3 will be 5 to the power minus 3 itself. Now, so again, we have arrived at the same condition of using the axiom of exponential equation. Here is base 5, here is also base 5. So that means if the bases are same, then yes, power can be equalized. Yes, powers can be equalized. That means 2x plus 1 will be equals to minus 3. So as we are actually looking for the value of x, now it is very easy type of linear equation which can be solved as sending this 1 on the right hand side. It will be minus 1. So 2x equals to minus 3 minus 1 will be 2x equals to minus 4. So we can easily cancel 2 and 4. 2 ones are 2, 2 twos are 4. So in this way, we got the value of x as a minus 2. All right. So this is the complete solving process for question number B. So I hope that this A and B are very much clear to you. All right then. Now let's proceed ahead, everyone. So let's talk about the C. Okay. Here I have given the base as in the form of fraction. So fraction, if you see the properly, there is 4 and there is 9. And on the right hand side, there is 16 and there is 81. Okay, so there are other so many ways. So I'm just going to talk any one of them. Okay, so if you see this question properly, 4 can be broken down further, whereas 9 also can be broken down further. That means 4 can be written as, that's right, 2 square, whereas 9 can be written as 3 square. That's good. So 4 is 2 square, 9 is 3 square. So that means 4 can be written as 2 square, 9 can be written as 3 square. And on the right hand side, if you see 14, 16 and 81, I think they can also be written in their lowest base, isn't it? Yes. So 16, what we can write for 16? Of course, 16 can be written as 2 to the power, 2 to the power 8. Yes. Similarly, 2 to the power 4, I'm sorry, 2 to the power 4. And how about 81? Yes, 81 can be written as 3 to the power 4. Yes, that's right. 16 can be written as 2 to the power 4. 81 can be written as 3 to the power 4. So the same thing you can see on the next step. All right. Now, again, if we take the help of laws of indices, one of the law, that means power law, if you see properly, then there is 2 to the power 2 and 3 to the power also 2. So of course, we can take this both power 2 as a common outside, isn't it? Whereas we can do the same thing on the right hand side also. There is power 4 and power 4, both of the numerator and denominator. So we can write 2 by 3, yes, whole to the power 4. Whereas on the left hand side, 2 by 3 whole to the power 2 times 3 into x, isn't it? Because power to the power will multiply. Yes, as we are taking power 2 from inside, there is already power 3x outside. That means power to the power, according to power law, they can be multiplied. So according to about the right hand side, we have explained already. Now, here also we have arrived at the same condition. That means here is base 2 by 3 on the left hand side and here is base 2 by 3 on the right hand side. That means our both left hand sides and right hand sides bases are being same. So we know that if the bases are same, then powers also will be same. So by taking this concept or by taking the help of axiom of exponential equation, 6x will be equals to 4. So that means 6x equals to 4. So as we are looking for the value of x, so I think they can be further taken down, it can be taken, so x will be equals to 4 by 6, so which can be easily broken down into 2 to the 4, 2 to the 6. So eventually we have come up with the answer x equals to 2 by 3. So this is how we solve question number C. Okay, I hope that you have clearly understood the idea of C. Now, let's talk about the last question, D number. Okay, which is like this. 5 by 4 whole to the power 2x equals to 64 by 125. Now, everyone, please pay attention properly. If we follow the same idea, some of you may think that 4 can be written as 2 square. That means the idea of breaking down the terms into its lowest term. That means 4 can be written as 2 square. But if you see 5 here, can 5 be written in terms of power 2? Yes. some of you might be thinking about writing root over 5 square, but let's not go up to that complex part. Simply, simple thinking. Think simply. Can 5 be written as something square without writing root? Of course, not possible. Yes, as it is easy to write 4 as a 2 square, we cannot write 5 easily in terms of something square. Okay, in absence of root. So due to that reason, it is meaningless, or it is not necessary to write 4 in terms of 2 square. I think you have all understood my thing, that what I am going to tell you. Because of this, 5 cannot be written in terms of something square. Okay, I'm not talking about root over 5 square, except that 5 cannot be written as something square. So it is not necessary to write 4 also in terms of 2 square. Okay, I think you can easily compare with C and D now. These two questions can be compared easily. Why we change here 4, but why we are not converting the 4 of D number? Okay, so now, so 5 by 4 remains same, 5 by 4 whole to the power 2x. But look at the right hand side. There is 64 by 125. Now, there are various ways to write 64, isn't it? There are various ways. Yes, 64 can be written as 4 cube also. 64 can be written as 2 to the power 6 also. There are various ways. But think about this 125. 125 can be in a single way, it can be written as 5 cube. Am I right? 5 times 5 times 5. Yes, 5 5 is 25, 25 5 is 125. So 125 can be written as 5 cube. So if it can be written as 5 cube, is there any possible way that this 64 also can be expressed in terms of power 3? We have two choices. Either we can write 2 to the power 6, or we can write 4 to the power 3. Yes. So to make it similar with denominator 125, we can choose the idea of 4 cube. All right. So the same thing that you can see on your first step. I hope that you have got the idea of writing 4 cube by 5 cube for the right hand side. All right. So now let's move ahead. As we know that we are not doing anything on the left hand side, but 4 cube by 5 cube, it can be written as 4 by 5 whole cube. That's right, yes. According to the power law, this power 3 can be taken out common. That's good. So 4 by 5 whole cube. Now, everyone, please let's not hurry. Let's think properly. Here is base 5 by 4, but here is base 4 by 5. They are not the same base. If you have noticed that in case of A, B, and C, all the previously solved questions, they were all bases were same. Even in this C number question, see, the left hand side base is also 2 by 3, and the right hand side base is also 2 by 3. But here we are getting opposite ratios. So now again, think further. Think further. If we use the idea of laws of indices here, then the things can be easier. That means let's change either left hand side base or right hand side base, numerator and denominator. That means for now let's change the right hand side. So if you see the right hand side, there is 4 by 5 is there. 4 by 5 is there. So if I just reverse the idea, there is 4 cube by 5 cube is there. So if I take 5 cube up and 4 cube down, it will be 5 to the power minus 3 up and 4 to the power minus 3 down, isn't it? So that means if I take minus 3 common, power common, then it will be 5 by 4 whole to the power minus 3. That's right, everyone. I hope you have understood the idea very clearly, everyone. If not, let me tell you again so that the things will be much more easier for you. See, we have 4 cube by 5 cubed is there. So according to the laws of indices, let's take 5 cube on the numerator so that it will be 5 to the power minus 3. And then let's take 4 to the power 3 on the denominator. It will be 4 to the power minus 3. Now, again, if we use the idea of power law, then 5 by 4 whole to the power minus 3 is there. So from this calculation, if we bring the concise idea, then 4 by 5 whole cube can be written as 5 by 4, but the power will be changed. That means positive will be negative, negative will be positive. That is the crucial idea. Okay. So by following the same idea, now we can write left hand side as it is. See, right hand side, in place of 4 by 5, I have written here, in place of 4 by 5, I have written here 5 by 4, and in place of plus 3, I have written minus 3. Okay, that means this sign will be opposite, or sign will be changed if we are just changing numerator and denominator's placement. Okay, so that's the idea. Now we have achieved the both bases same, 5 by 4 base, 5 by 4 base. So if the bases are same, according to the axiom of exponential equation, powers can be equalized. So in this way we have got the value of x as a minus 3 by 2. So these are the example, 4 examples I have given you here, which can be so much helpful for you to understand the idea of exponential equation. Okay, so these are very much important idea. Now I would encourage you all to try out these questions. Okay, these are the classwork questions, or you can take it and then you can think about how we can do these questions. And I'm sorry that this G number question is seems a little bit complex one, but I still hope that the laws of indices will be so much helpful for you. Okay, because you know that root is, yes, root is power 1 by 2. So that means you can on the next step easily write 3 to the power x minus 3 by 2. That's right, yes. Root can be expressed in terms of power, or if you don't want to deal with this kinds of thing, then obviously there is base root 3, there is also base root 3, isn't it? So why to go up to so complex area? If the bases are same, powers will be same. So that means x minus 3 equals to x plus 2. Okay, but actually if you consider me, I would give you one thing, that I would write this one as a 2. Okay, so 2x minus 3 equals to x plus 2. So in this way you can solve it and get the values of x, and I think E and F will be so much easy for you. Okay, thank you so much. I think you have got the idea in a very clear way. Thank you.